Hello everyone and welcome to another episode of Interstigation. In today's episode of Interstigation, I will go over the constant multiple rule, or often simplified to CMR. CPR, that's not a math related topic. Okay, CMR. So in this rule, we are basically trying to take the derivative of, you guessed it, some coefficient times an arbitrary function. So this is what we want, and let's take an intuitive sense of it as always. So if I draw a graph over here, let's draw it using a thin line. So if I have a graph over here, let's say let's create a linear function first. So linear function going through the origin. I really want it to go through the origin. Okay, and another. So let's say this function is defined by f of x is equal to x, and this one is defined by f of x is equal to 2x. Obviously, the slope, because it's constant in a linear function, we always have the derivative of this f prime of x. Wait, actually, I don't want that to actually be named f. That's sort of confusing. So g of x. So if we have that, then we definitely get that f prime of x is equal to 1 at all points, and this slope g prime of x is equal to 2 at all points. So that is definitely k times. Now let's take a look at a different function. So let's say, let's take a look at quadratics. Quadratics are one of the most used functions as well, or polynomials in general. So let me just draw a quadratic, and let's vertically shrink it. So sort of like this, still by a factor of 1/2. So like this. So if we have this, then if we define this as f of x is equal to x squared, and this g of x is equal to half x squared, then if we take an arbitrary point on the graph, let's say if we have this point over here, then let's say this is 2, then if we have the slope through this point, actually let me make it in black, slope through this point like this. It's not perfect, but the slope through this point like this, and we want to find the relationship of these 2 points, their tangent at both of these points. So we've learned the power rule. Let's take the power rule. So the power rule is f prime of x is equal to this come down here and the power minus 1, so that's 2x, and this one, this come down here, so that will just become x. So f g prime of x is equal to x. So as you can see, at any point on this graph, we would have a 2-to-1 ratio of the derivative or the slope, basically the same thing. So let's actually prove it using the calculus way of derivative definition. Recall that our claim is actually this. So d dx of this is equal to k times, we have all of the d dx of f of x, or it can also be written as k times the f prime of x. They're basically the same thing if this is true, so we want to prove this. And by proving this, we are again using the definition of derivatives. In the beginning of the rules, we often use the definition to just set up some basic rules so that we can use later in deeper calculus. So first of all, let's set a function of g of x, and let's set that to be equal to k times f of x. And if we have that function defined, if we want to take the derivative of g of x, we get g prime of x is equal to the limit as h approaches 0, and we have this g of x plus h minus g of x over h. We want to get rid of all of the g because this is a function that we set up and we actually just want everything in terms of f of x. So that would be g of x, just expanding it using this function, this definition, so we can get that as limit as h approach 0, get k times f of x plus h minus k times g, k times f of f of x all over h, and that would just be g of x using the property of limits, which I assume you know because this is derivatives and you should have learned limits before this. So as limit as h approaches 0, if we take out the k in front of the limit, then we get that this will be f of x plus h minus f of x over h. And if you examine this, that's not what I want. If you examine this, you will realize that is exactly the definition of f prime of x, which is the derivative of f of x. So that would just turn into f prime of x. F prime of x. So there is a k in front of it, and that is g prime of x. And we can, of course, rewrite this as k times d dx of f of x, as that is basically the same thing. And now we have proved the constant multiple rule. Thank you for watching this episode of Interstigation, and I will see you in the next one, where we will be going over the sum and the difference rule. Goodbye.